let's wait for another minute, maybe a couple of, at least a half minute, to see if we get some more people coming into the lobby. So let's start. I think we have some people now. We don't have anyone in the lobby right now. Welcome everyone back to track 4, quality testing. And now we are coming to the end of this day in this track. This is our last presentation for today, nevertheless. And we will move into the security test area. It's an interesting area, and I guess it's a lot of challenges within this area. Our last speaker is a security architect who is, among other things, heavily involved in the non-profit organization OWASP. A good day for Viktor is to work when he can work close together with the development team to increase knowledge about security. And therefore, I would like to welcome Viktor Lindstrom. Welcome, Viktor.
Thank you so much. And welcome. Let's talk some security testing. So what we'll go through during this session is some testing fundamentals. What kind of testings are there? And we will focus on testing for your code, application security testing. I've done something about me. My name is Viktor Lindstrom. I work as a security architect at Wireless Car. Previously been at Volvo Cars for a couple of years. To be able to test a secure application, we need first to understand what a secure application is. And a really easy definition of that is to say that a secure application, that is an application with an absence of security vulnerabilities. Without any vulnerabilities, it is a perfectly secure application. This definition is a bit hard, and we can also argue about secure application in the context of predictability. A predictable application is a secure application. If you know how the application is working to a full extent, you will also have a secure application. Let's take this example. You have an application. It's the simplest application you can imagine. It does one thing. And to test that application, you have some input data. You put that input data to your application and you verify the output of that data. You match that against some acceptance criteria. And you will have a correct or false. You will have red or green. You can say that this application is fulfilling that acceptance. But that application also has very likely a lot of unintended behavior. Behavior where the application isn't working as you intended. The application is not fully predictable. All unintended behavior is not security vulnerabilities. But the majority of security vulnerabilities is unintended behavior. And we can look for that unintended behavior. We can increase the sort of search space for the tests. And we can find more parts of the unintended behavior of that application and sort of try to define that and make sure that that is not a vulnerability. To help us doing this, there are a couple identifiers, indicators, to sort of indicate when an application is more vulnerable than other places. Which application and where in that application do we need to focus our testing? Complexity is one of those places. A complex code base is an indicator that you have unintended behavior because it's harder to understand. Test coverage. If you have more test coverage, you're more likely to know the intent of the application. This is a this is very usually a very black and white discussion and a heated discussion with test coverage. But I argue that while you're writing your code, the intent is very much there. You know the intent of the code while you're writing it. The same goes for old code. The intent of that might not have changed in a long time, and it won't change. But if you write tests and have good test coverage while you're doing it along the road and new code is added, the assumptions you made while you wrote that code might have changed. And the test is one sort of gate where you can catch that intent, where that intent changes. Other bugs is also an indicator for unintended behavior, which can lead to security vulnerabilities. There are specific patterns within the code that you can look for that indicate security vulnerabilities. Dependencies. If your code has a lot of dependencies, old dependencies to versions that has security vulnerabilities, it's more likely to inherit those vulnerabilities to your code too. If you have existing known vulnerabilities, you're more likely to have more vulnerabilities. The first types of testing that will help out to find these and make use of these indicators, at least part of them, is the absolutely wonderful named static application security testing, SAST. What that does, that it will look at your code, the static code, the dead code, and it will find patterns, match those patterns toward a database. Those patterns are usually called signatures, and it will mark those lines where the signatures is indicating that this is a place where you have a vulnerability, where it's likely that you have a vulnerability. It can also do that in different levels usually, to say that this is a more likely and also a more serious vulnerability. Here is an example. We have two pieces of the same program. The program is rather easy. It takes a random number and outputs. It creates two random numbers and outputs them. The left one imports Java till random. The right one is importing Java security secure random. By looking at them side by side, it's rather easy to see that util random is obviously not secure since there are a secure random, right? But if you haven't seen the secure random of these two, it's not as clear. And that's where these tools sort of is a really good tool for us. When you've found your vulnerabilities and when these tools are usually going through all your code, not only finds the specific vulnerability, it will usually also group them together. Open Web Application Security Project is an organization that does a lot of security things, but part of what they do is to create the top 10 list. Every 3 or 4 years or so, they created top 10 list of the most common vulnerabilities for web applications. These are obviously also very much interesting for your application, even if it's not a web application. But this grouping helps us reason about the vulnerabilities. They helps us understand how to protect against them and also look for them. Another place that's really good where you will see references from within these tools is CWE, Common Weakness Enumeration. These identifiers explain the weakness, and I think this is one of the underutilized places for security, where I often meet people that have seen the numbers but have never seen what they actually provide for information, what they actually mean. If you see these references, I recommend you to actually go to MITRE.org and look that specific identifier up. It has a lot of good information. It explains what the vulnerability is, have some description about it, and also provides a couple of examples. Use those examples and create tests. To summarize a bit, it's usually very much discussed the false positives when it comes to these kind of tools. As I started off, these are indicators, and it will indicate that this is a place for you to look at. See it as a help that will show you parts of the code to analyze instead of your whole code base. It will also sort of yield not only a red marker for your code, it will also give you a short explanation on why that is an issue. Keep in mind that you need this to work together with everything else. This is not a test you can do in isolation. These tests needs to be run very much integrated. The next type of tool and testing is dynamic application security testing, DAST. Dynamic testing is, as the name sort of hints about, your running application. These tests will be done towards your running application. And a couple of benefits from that is that it will find configuration errors. It will probably find bad defaults. It will just, in the same way as static testing, use a simple database of common attacks and try them. It has indicators for what kind of input usually yields an output that can be verified, and see if that is sort of indicating of a security vulnerability. Again, this is indicators. You're more likely to have something that is testable and easier to reason about when it comes to dynamic testing. That is my observation, at least. But again, you won't find, for example, dead code that is not referenced anywhere, that might be referenced in the future, will never be found with dynamic testing, but it might be with static testing. And the kinds of the types of signatures and the types of findings are a bit different. Again, it will find working examples, often provide that. What I mean with that is that you can have a request in your hand that sort of shows you that the application won't work after you try that out. I also wanted to include team-crafted tests into this. This is usually not a tool that creates a test for you. It's sometimes referred to as negative testing. it doesn't have anything to do with being in a bad temper when you do the testing. It has to do with the validation. So if you do a testing of authentication, a specific set of username and password should grant a user. And you can have a test for that and see that, yeah, that actually accepts. But the other way around, if you have a bad password, you need a test to verify that that also fails, hence negative. Security application is not necessarily secure application. Test your security controls. A good place to start doing these kind of tests is at point of transformation, data transformation. Places where you assume that the data looks in one way and then transform that. That is places you can start doing these kind of tests. It's both easy to reason about what you assume that the data is, but also something will happen with the data and you can verify that that is intended behavior afterwards. One example of these assumptions for unintended behavior is this domain name. This domain name is pointing to your local computer. It's a special one, and it has a special IP address. The point I want to make here is that you assume that IP address looks in a specific way. Did you know that you can omit the zeros? If you have an assumption and if you don't test for this, this is valid behavior. So other integrations might have these functionalities to work with this. And you, of course, you can do it in even weirder ways. You can represent the IP address as a hexadecimal value. And it's really hard to unlearn the way a simple IP address looks like and similar things. And you could even represent this as other things such as octal and so on. What I mean is that we are doing a lot of assumptions when we are doing testing, and it is hard to get away from those assumptions, but do try, even when it's crystal clear that this is supposed to be this and this will never change. It's very rarely that is the case. The next type of testing is dependency analysis or software composition analysis. Your application often is composed of multiple libraries, not only your own code, but other libraries which you import. These tools, they combine these dependencies, or they combine the names of them and version into a list, usually called a software bill of materials. Then it compares that to a database. One of these databases are the National Vulnerability Database. This database contains a mapping between these versions and libraries and vulnerabilities, reported known vulnerabilities. With this mapping, it then reports. These libraries are green, these libraries are yellow. And you get a report afterwards. It's a really nice tool. Keep in mind that dependencies can get vulnerabilities over time. So you need not only run this at build time, you will need to run this consistently. The vulnerabilities can be reported whenever. Other places where we can find security testing and sources of our test is to look at the monitoring we have. Chances are that you are deploying your application on internet. And if you look into your monitoring, you'll see that it's not only your valid requests that are requesting your web page. I would hazard to guess that you're very likely to actually have someone trying to do generic exploit from long ago every day or so. Take a look at that monitoring and see if this is reasonable for your application. And if it is, do some Googling. Maybe you can generalize it a bit, create a test for it. Even if it's obvious that your application is secure from it today, it might not be in the future. And you have quite clear proof that someone is trying these things out. And if they are trying it today, it's not unlikely that they will stop trying it. I also wanted to include results from penetration testing. When you're doing a penetration testing or a simulated attack, so to say, make sure that you ask them to include what they tested. That's a perfectly fine thing to do and ask for. When they are done with their simulated testing and reporting that you need to fix all these things, you can also include tests. You can see what they did, what kind of request did they do, and what was the result from that. And you can make sure that you don't introduce these things again and have the same sort of looking pen test report the week after. Also, you have the possibility to check other places within your code. Another place where you can find good help when it comes to starting off is compliance. Usually gives you a good list of rated places to start. I underlined what ASVS, Application Security Verification Standard. This standard is a list of tests grouped into what kind of application is assumed and then rated in 3 different levels. So you can choose which level you think you are and look for those tests. And that could create a good basis for you. The same goes for NIST and SIS. These kind of compliance standards has a lot of different controls. But look at them and see if someone makes sense to you. Some of these controls make sense to you, and have that as a starting point. In the end, it will sort of move you further along, and it will help you do the right thing first, since it's usually rated. Okay, some summary. Static Application Security Testing, SAST. That is a really good testing tool. And type of testing that tests your dead code. And I mean dead code, not running code. The database of vulnerabilities is usually contained within the tool. All of these different applications, and especially SAST, needs to be very much included and integrated to your tools. Dynamic testing, the same goes there. It cannot be run in isolation and then reported back to developers. It has to be integrated into your build pipe. The only outlier to this is somewhat compliance, but I argue that you should do that too, in close to the development lifecycle. And it's not pick one and then you're fine. You should use all of them to a different extent, depending on what kind of application you have. Some ending remarks. Push left. If you haven't heard it, that means do things early in the life cycle. And I mean really, really early. Don't argue why you should remove stuff from a code base. Argue why you should put them in. Automate and communicate. Integration and reporting. If you look for buying tools or implementing tools, look how well they automate and integrate into your current situation and your style of development, your leadership. And choose that tool that makes most sense for you from that point of view. It makes more sense to look at that than look at how many false positives it gives. That was actually all I had. Questions?
You can either unmute or you can write your questions in the chat. It's up to you. But it's nice if you would like to unmute and ask your questions. I have a question. Have you found out any smart way to communicate new security threats out in a fast way to your developers?
Yes. I cannot hear you now. I see your mouth is moving, but I cannot hear you.
Did you hear my question?
I think so.
Huh?
How to communicate security to developers.
Yep.
Is that correct?
Yep.
Yes. Don't act as they have made. Make sure that they gain help. Don't find security as something that they've made wrong. It needs to be interesting, exciting, and now I see your mouth is moving again, but I don't hear you.
I don't say anything right now.
Okay. Then I probably see. Right. But for specific things, capture the flag challenges is usually a lot of fun, where you do challenges usually related to security to aid sort of education by a bit of experience. I see the question. Would you say that security testing requires other skills, education background than other types of technical testing? I would like to say no. It requires some assumptions to be removed. It requires some curiosity to look for other places to look for things that you don't assume to be there or others assume not to be there. But I don't think that you need special education. You need an interest and you need to have gotten inspired about it. Then I think you're have all the chances to do good things. Hopefully that was a good enough answer. But I think it's more coupled to assumptions you make. Having a good grasp of a lot of basic protocols and so on makes it somewhat easier. But a lot of times it's making it's making tests. So I don't think that it's special from any other test making. Is there any security testing framework to use, or do I need application-specific scenarios? Sometimes you need application-specific scenarios. Some tools that can be used, the dynamic tools, examples of that, I could name some open source.
Not sure what happened now. Can you still hear me?
Yeah, I hear you, but I think we lost Victor.
I think we lost Victor. Yeah, I agree.
He's on his way.
I think he's on his way in again. See if we can.
Sorry, my browser kicked me out.
Welcome back.
Thank you. Specific tools that can be named. UVA-SAP is a tool for dynamic testing. It contains a sort of a database coupled to mainly web applications. If you start to search for these terms, dynamic application security testing and static, you will find a lot of different tools. All of them is saying that their unique selling point is the least amount of false positives, and it will be really, really good for your application because you will only see what is actually the true vulnerability. I'd say look at the reports and example reports, and that will yield you a better result when you're choosing the tool. But search for the terms SAST, DUST, SCA, and you will find tools. I don't think that you should rely on one tool. I don't think that you should only rely on tools. It's really fun to write these kind of tests. When you find that one of your assumption is not true, it's usually rather fun. And you can test it on your friends' applications, discuss with them, buy them a coffee, have some fun with it. Yeah, both is my sort of answer. Since you know the business function of your application, you usually have an easier way of reasoning about what is assumed to be input or not. A program that you bought will not be able to look at a specific data point and say that this should be a UUID of this type, or this should be a only 5-letter name. Those kind of constraints, it's usually developers close to the application that knows. And keep those tests close and test for that to fail.
Hey, have we defined on all questions in the chat now? The test coverage question, can you see what one, Victor?
I don't think. Is test coverage applicable when it comes to security testing? How do one assure that application is secure? All right, so one of the things that you should be very wary about is when people say that the application is secure. It's really, really hard to find your application as secure. It's more or less unsecure, so to say. I think that test coverage has a place. Maybe not forcing 100% if it's not test-driven development that you're doing, because you need to couple this with some business value and the rest of the company. But test coverage definitely has a place, and it shows that you have done testing and what to what extent. And yeah, I think that that is one of the indicators. And if you look at the sort of image I started off with the indicators, those are good places to start. Look at. If I would do a test for an application where the application has complex places and I don't understand what the code does, that is a good place to start to look for security things. Because if I don't understand how that application is working, there is a chance that the person who wrote it didn't understand it fully, or someone else along the line that tried to understand it. And where you don't understand how it works, that is likely to have unintended behavior. Unintended behavior is closely related to security vulnerabilities, I argue.
Any more questions? Otherwise, I hope if some questions pop up later, they can be dropped to you directly, Viktor.
Of course.
Okay, thanks. Thank you very much for your super interesting presentation today. We will wrap up this track 4, quality testing. This was the last speaker we have in this track today. So thank you very much for hanging out during track 4 with us during the day. We have had a lot of very interesting speakers. They have has been very different topics that we have been listened to. So now what will happen the rest of the day? There is some other tracks still ongoing. For example, in track 1, you can attend in a debate, or you can attend in track 2, where there are still some speakers left. So and track 3 also have a speaker session left. And then at 20 minutes to 4, we will have a wrap-up session. And it's not 100% clear which link to use yet, but it will be announced on SAST.se. And most likely it will be the same link as we use for the introduction, but I'm not 100% sure about that. So thank you very much for listening and hanging out with us in track 4 today. Thanks a lot.
Thank you.